Usually when we talk about medical diagnosis, there's this expectation of, well, precision.
Right, like it's a binary thing.
Exactly, like engineering.
Yeah.
You break your arm, the x-ray shows that jagged white line, and the doctor just points at the screen and says, there it is. There's the break.
Yeah, it's clean, it's either broken or it isn't broken.
Right. And honestly, that's comforting. I mean, we naturally like things to be visible, to be categorized. We want things to be black and white.
But then, you step into the world of construction claims.
Oh, boy.
Yeah. You try to diagnose the trauma, the delays in the schedule of a massive infrastructure project, like, say, a multi-billion-dollar airport or a high-speed rail line, and suddenly that X-ray machine is completely useless.
Just shows static.
Exactly. You're looking at a diagnostic landscape that is entirely murky.
It is the absolute definition of diagnostic muddy waters. Because, when a project of that scale goes sideways, determining exactly who caused the delay, when they caused it, and, most importantly, who actually pays for it, is never as simple as pointing to a single jagged line on a chart.
No, it's not. It's a tangled web. You've got overlapping failures, you've got bad weather, design changes, resource shortages all hitting at once.
And unraveling that web is really what separates the true experts from the amateurs in this field.
It absolutely is.
Which brings us to our mission today. So, welcome to a highly specialized premium coaching deep dive. Today, we are conquering Class 2 construction claims.
The heavy hitters.
The heavy hitters. We are going to unpack advanced delay, extension of time, which, by the way, you'll hear us call EOT throughout this disruption and prolongation. And we are going to do this by simulating the environment of a high-stakes assessment of professional competence interview.
Right, an APC masterclass.
Exactly.
Yeah.
This is the crucible.
It really is. It's the final hurdle that professionals, like chartered quantity surveyors, have to clear to prove they don't just understand the academic theory.
Right. Anybody can read a book.
Yeah, but can you actually apply it under extreme, unforgiving pressure? That's what the panel wants to know.
So here is the premise for you listening today. I am going to adopt the persona of the rigorous, highly critical, and perhaps slightly intimidating APC assessor.
I'm already sweating.
Good. I'll be throwing complex, real-world, scenario-based questions at you. And my co-host here will play the role of the ultimate, unflappable candidate and claims consultant, providing the model answers and, breaking down the logic.
I am ready. Bring it on. And just so you know what's informing this, we are synthesizing some incredibly intense gold standard material today.
The real deal.
Yep. We are pulling from the definitive industry protocols on delay and disruption, alongside the most comprehensive competency preparation guides used by chartered surveyors globally.
And we aren't going to get bogged down in citing specific document names or authors. We really want to focus purely on the mechanics, the law, and the practical application.
The stuff you actually use.
Right. So whether you are actually prepping for your own professional interview, or maybe you are managing a messy construction project right now and trying to figure out where the budget just bled out.
Or if you are simply fascinated by the high-stakes chess match of contract law.
Yeah. This deep dive is going to give you the tools to definitively separate a valid, ironclad claim from, well, complete hot air.
Let's get into it.
Okay, let's unpack this. Because before a project can be delayed, before we can even talk about claims, it has to be planned and budgeted.
You have to have a baseline.
We need to set the baseline. So let's enter the APC arena and look at the first core competency, cost planning.
Right.
If I'm a candidate walking into this assessment, what is the actual physical environment I'm stepping into?
Well, you are walking into a highly structured, fiercely timed environment. Generally, this interview is a 45 to 60-minute trial by fire. Yeah, you walk into the room, the panel of assessors welcomes you for about 5 minutes, and then the spotlight is entirely unforgivingly on you for your initial speech.
And I imagine this isn't just a casual, hey, tell me about your background kind of chat over coffee.
No, absolutely not. The parameters are explicit. You must utilize exactly 10 minutes, not 9 minutes, not 11 minutes, exactly 10.
That is intense. What do you even talk about for exactly 10 minutes?
You have to clearly articulate your educational qualifications, your professional memberships, and then you dive deep into your work experience. You need to detail the nature and value of the projects you've worked on.
So like, were they commercial buildings, regional airports, heavy civil infrastructure?
Exactly. And you must state the specific forms of contract used, like FIDIC or JCT, and highlight your specific duties. especially any non-standard procurement methods like cost-plus projects or management contracting.
It's basically a test of communication, precision, and time management right out of the gate.
Exactly. Because if you can't manage 10 minutes of your own time, how on earth can you manage a 5-year project timeline?
That makes total sense. So let's assume the candidate survives that opening gauntlet. The panel then starts drilling into the core competencies. Let's look at the budgetary process. How are cost limits actually established during the life cycle of a project?
Well, industry standards usually map this out through specific stages of work, from inception to completion. There is a fundamental template for the construction process, the REBA plan of work, that maps a project from a client's initial vague idea all the way through to final demolition.
Okay, so when we talk about cost planning, we are really focusing on how costs are managed from that very first appraisal stage, right through to the production of detailed technical info.
Exactly.
Let's start at that first stage, the appraisal or concept stage. The client literally just has an idea. They say, I want to build a 50-story office tower downtown.
Right.
They don't have blueprints. They barely have a napkin sketch. How do you even begin to put a reliable number on that?
At that initial stage, you are providing what's known as an order of cost estimate. Because the design is barely conceptual, you have to use preliminary estimating methods to establish a highly provisional cost limit.
Highly provisional, meaning a massive guess.
An educated guess, yes. The standard guides list several of these methods. You have the unit method, the superficial area method, the cube method, and the story enclosure method.
Okay, wait, slow down. So you take the basic high-level parameters of the proposed building and multiply them by historical cost data.
Yes, that gives the client a ballpark figure so they can decide if the project is even financially viable enough to hire an architect in the first place.
Let's drill into those methods. The unit method seems obvious. Like if I'm building a hospital, I calculate the cost per bed based on past hospitals I've built.
Right, or if it's a car park, it's cost per parking space.
But what about the superficial area method versus the cube method? What's the actual mechanical difference there?
Well, the superficial area method is probably the most common. You calculate the total floor area of the building and multiply it by a historical cost per square meter. It's straightforward.
Yeah, that sounds easy enough.
But it has flaws. It doesn't account for the height of the building. And that's where the cube method comes in. You calculate the total volume of the building, so length times width times height, and multiply that by a cost per cubic meter.
Ah, I see. So the cube method would be way better for something like a massive warehouse or an atrium,
Yeah.
right? Where there's a lot of empty vertical space that still needs exterior walls and climate control, but there's no actual floor area.
Exactly. But you have to remember, even then, as the design gets more detailed and you move into the subsequent design stages, those ballpark figures just won't cut it anymore.
Right, because now the architect is actually drawing floor plans. We are moving from an idea to an actual building.
Precisely. And at this point, you transition from an order of cost estimate to an elemental cost plan.
Elemental cost plan.
Oh, this is a critical pivot. You are breaking down the overall massive cost limit into specific ring-fenced cost targets for each functional element of the building.
So instead of just a total number of, say, $50 million, you break it apart.
Yes. You now have a target of $5 million for the substructure, $10 million for the frame, $3 million for the roof, and so on.
I see. And the psychological shift here is huge. The goal is to design to a cost, rather than costing a design.
That is the golden rule of cost planning. The elemental cost plan provides a rigid frame of reference. As the design develops further, the cost planner carries out continuous cost checks to ensure the design team isn't blowing past those elemental targets.
Because architects love to get creative.
They do. So if the structural engineer suddenly designs a complex steel frame that costs $2 million more than the target, you have a problem. You either have to force them to simplify the frame, or you have to find $2 million of savings in another element.
Like downgrading the lobby finishes or the HVAC system.
Exactly, just to maintain the overall cost limit.
Now, to make any of these estimates work, whether it's that initial order of cost or the detailed elemental cost plan, you have to measure the physical building accurately. The competency guides are incredibly strict about area definitions. This feels like a trap where a lot of disputes could start if the baseline measurement is wrong.
It is fundamental. If your area measurements are wrong, your entire cost plan is compromised from day one. You are multiplying a rate by the wrong number.
A nightmare.
Yes. The industry rigorously defines 3 key metrics: gross internal area, or GIA, gross external area, or GEA, and net internal area, or NIA.
Okay, let's play this out so I understand it. I'm guessing gross internal area, the GIA, is basically everything inside the outer skin of the building.
Essentially, yes. GIA is the total horizontal area of the building measured to the internal face of the perimeter walls at each floor level.
So it includes usable areas, circulation areas, plant rooms, stairwells, internal structural columns, basically everything inside that outer shell.
Right. But it crucially excludes things that are outside the thermal line, like open balconies, canopies, and open parking areas.
Okay, so GIA is the footprint you were actually heating and cooling. What about gross external area, the GEA?
GEA measures to the external face of the perimeter walls, so you are including the physical thickness of the exterior walls themselves.
Oh, interesting. So that adds a bit of square footage just in concrete and insulation.
Yeah. It also includes those inbound balconies that GIA excluded. GEA is primarily used for town planning, zoning purposes, and calculating the overall footprint of the development for the local municipality.
And net internal area, the NIA. I imagine this is the one the tenants actually care about.
Absolutely. NIA is the strictly usable area. It's measured to the internal face of the perimeter walls, but you subtract all the non-usable spaces.
So you exclude the plant rooms, the lift shafts, the stairwells, the common corridors, the shared toilets, and the internal structural columns. Wait, so if I'm a corporate tenant leasing a floor in a high-rise, I'm not paying rent on the space taken up by the elevator shaft or the structural columns.
Correct. NIA is essentially the space a tenant can actually lay carpet on and put a desk on to run their business. It's the metric most often used for leasing, marketing, and the financial valuation of commercial real estate.
So if you mess that up,
If you confuse GIA with NIA when building a cost plan for a commercial developer, you will wildly overstate their potential rental income, and the project could literally go bankrupt.
all right, I think it's time to step into the role play.
Let's do it.
Let's say we are sitting in the interview room. The panel leans forward. Candidate, listen carefully to this scenario. A developer client asks you to provide an initial order of cost estimate for a new, highly complex, high-rise residential tower. They instruct you to produce this estimate purely by taking the historical superficial area cost data, the cost per square meter from a similar high-rise project they completed 10 years ago, and just multiplying it by the new tower's gross internal area. As a competent cost planner, what are the inherent risks of accepting this instruction, and how do you advise the client?
Okay, here is the model answer. While utilizing historical superficial area data is a recognized preliminary estimating method, relying on unadjusted, decade-old data without applying rigorous benchmarking introduces severe risks to the cost plan. This approach could lead to a catastrophically inaccurate order of cost estimate. The industry competency guides explicitly outline the pitfalls here. Firstly, historical cost data is never 100% reliable as a direct copy-paste.
Makes sense.
Secondly, no two buildings are identical. A high-rise from 10 years ago will have vastly different regulatory requirements, fire safety standards, energy efficiency mandates, and architectural complexities than one designed today.
Right, regulations change constantly.
Exactly. Thirdly, relying solely on an old rate completely ignores the crucial need for benchmarking adjustments. I would firmly advise the client that to provide a professionally competent estimate, the historical data must be adjusted for several factors. We must apply a time factor to account for 10 years of compounding construction inflation. We need a location factor if the old project was in a different city or a less congested site.
Oh, like building in London versus building in the countryside.
Right. We also need a specification factor to adjust for current material qualities and client expectations. Finally, a 10-year-old rate will not accurately reflect the current risk allowances and market conditions required by contractors today. Proceeding to estimate without applying these benchmarking adjustments would border on professional negligence.
Okay, that completely changes my perspective. To put that in an analogy for you listening, using an unadjusted 10-year-old cost per square meter to plan a modern high-rise is like trying to use a street map of London from 1910 to navigate today's traffic.
Yes.
Sure, the River Thames is still in the same place, the general shape of the city is there, but everything else, the congestion charges, the new one-way systems, the pedestrianized zones, the modern traffic lights, has completely changed. If you don't adjust your navigation for the time factor, you are going to crash your car.
That is a perfect way to look at it. The baseline has to be rigorously accurate and contextualized, or everything that follows, including any future claims for delay or disruption, will be built on a foundation of quicksand.
Which brings us perfectly to the next phase of the project lifecycle. We are moving from the pristine, theoretical pre-contract cost planning into the messy, chaotic post-contract realities of contract administration.
The real world.
The project is underway. The concrete is pouring. Millions of dollars are moving every week. But suddenly, an employer risk event happens. Let's say the employer completely fails to give the contractor access to a critical part of the site on the agreed date. Progress is instantly derailed.
Chaos ensues.
Exactly. The contractor furiously submits an application for an EOT, an extension of time. Let's start with first principles here. What is the actual mechanical purpose of an EOT?
Well, according to standard industry delay protocols, an EOT is not just a free pass or a get-out-of-jail-free card. It serves two very specific, highly consequential legal and commercial purposes.
Okay.
For the contractor, the primary benefit of an EOT is to relieve them of liability for damages for delay, which are usually levied as liquidated damages, or LDs, for any period prior to the newly extended contract completion date.
Let's clarify that for the listener. Liquidated damages are basically a pre-agreed punitive daily penalty the contractor has to pay the employer if they finish the project late, right? Like $10,000 a day for every day past the deadline.
Exactly. So the EOT acts as a legal shield against those penalties when the delay genuinely wasn't the contractor's fault. But it also has a massive, often misunderstood benefit for the employer.
How does extending the timeline benefit the employer?
By formally granting an EOT, the employer establishes a new, firm contract completion date. This prevents a very dangerous legal situation where time for completion becomes what is known as time at large.
Time at large. That sounds ominous. We need to deep dive into that concept. What does it actually mean for a multi-million-dollar contract to suddenly lose its completion date?
It's essentially chaos. Let's say the employer delays the contractor, perhaps by issuing a massive design change late in the game. But the contract doesn't have a mechanism to extend the time, or, more commonly, the employer's contract administrator improperly refuses to grant a valid EOT.
Right.
Under common law principles, the employer cannot hold the contractor to a deadline that the employer themselves has prevented the contractor from meeting. So the original completion date completely falls away. It evaporates. The contractor is then only legally obliged to complete the works within a reasonable time.
And reasonable time is incredibly subjective.
Exactly. It's a lawyer's dream and a project manager's nightmare. But worse for the employer, once time is at large, the employer loses the right to apply those liquidated damages entirely. They can't charge the $10,000 a day penalty anymore because there is no firm date to measure the delay from. So the EOT mechanism is actually there to protect the employer's right to hold the contractor to a specific enforceable deadline.
Okay, so the EOT is a vital mechanism for both parties to maintain order. But here is where it gets really contentious in the real world. A massive issue on construction sites is how contract administrators, who are often paid by the employer, handle these applications.
Yes, the notorious wait-and-see approach.
Right. A contractor submits a legitimate claim for a delay that just happened yesterday, and the contract administrator says, look, there's a lot going on. Let's just put this claim in a drawer. We'll look at it at the very end of the project and see if you actually finished late.
And the industry delay protocols explicitly and emphatically condemn the wait-and-see approach. The protocols state that the parties should attempt to deal with the time impact of employer risk events as the work proceeds.
It's called contemporaneous analysis, right?
Yes. Applications should be made and dealt with as close in time as possible to the delay event itself.
I won't push back on this because if I'm the employer, reading seems infinitely safer. Why should I grant an extension now when the contractor might miraculously catch up on the schedule later? If I wait until the end, I only grant the exact amount of time they actually needed. Why do the protocols hate this approach so much?
Because it fundamentally and structurally prejudices the contractor. The protocol notes that the goal of the EOT procedure is to ascertain the appropriate contractual entitlement to an extension, not to look backward at the end of the job and see if the contractor needed it to avoid LDs.
So what's the alternative?
To facilitate this, standard practice recommends an incremental review of EOTs.
How does incremental review work mechanically?
Well, where the full effect of an employer risk event cannot be predicted with total certainty at the time it happens, which is almost always the case, the contract administrator should immediately grant an EOT for the predictable effect of the delay based on the information available today.
Okay, so a partial extension.
Right. Then that EOT should be reviewed at regular intervals as the actual impact unfolds on site. The EOT can be increased later if the situation gets worse, but crucially, it cannot be decreased unless the specific contract explicitly allows for it.
All right, let me throw an assessor scenario at you. Candidate, I am acting as the employer's contract administrator on a major infrastructure project. a new subway line. The contractor has submitted a complex EOT application for an employer-caused delay regarding site access that occurred last week. The project still has 2 full years to run. Why shouldn't I just adopt a wait-and-see approach until practical completion? Surely, waiting to see the actual final effect on the completion date protects the employer's financial interests and avoids granting unnecessary time that the contractor might just use as a buffer.
Okay, here is how I would answer that. Adopting a wait-and-see approach directly contravenes the recommendations of standard delay protocols and represents poor contract administration. The protocols expressly discourage this practice for several critical reasons.
Proceed.
First, an EOT is designed to provide commercial certainty. The contractor needs to know their revised contract completion date contemporaneously so they can properly reprogram the remaining works, make informed logistical decisions about resource allocation, and implement effective mitigation or pacing strategies.
So they need a target to aim at.
Exactly. If you withhold the EOT and keep them in the dark, you force the contractor to try and work toward an impossible, outdated date. This forces them to pour extra labor and resources into the project to catch up on a delay they didn't cause, potentially causing them to incur massive, unnecessary acceleration costs.
Which they will then sue the employer for.
Yes. A situation legally known as constructive acceleration. Secondly, if a contractor is contractually entitled to an EOT, they should receive it immediately. The assessment must be based on the reasonable prediction of the delay at the time of the event, not an ex post facto review of whether they ultimately needed it. Therefore, I would advise that we grant an EOT for the predictable effect right now and utilize an incremental review process to increase it later if the unfolding event dictates.
That is a rock-solid answer. It feels exactly like an insurance company refusing to approve an urgent surgery.
Oh, that's a good analogy.
Yeah, imagine you're in a terrible car accident. You need an operation to save your leg. You submit a claim to your health insurance. And the insurance company replies, well, we are going to adopt a wait-and-see approach. We're not going to approve the funds for the surgery right now. We'll wait 6 months to see if you actually survive and keep your leg without it.
That is brutal.
Right. If you survive, clearly you didn't need the surgery and we save money. If you lose the leg, well, we'll process the claim then.
It's an absurd, cruel logic, right? But that is exactly what contract administrators do to construction schedules every day. They starve the contractor of the certainty and the time they need to survive the project. The schedule needs the surgery, the EOT, immediately so the project can heal, recalibrate, and move forward efficiently. If you make them wait, the project bleeds out.
Absolutely. So we know that to get an EOT, the delay has to actually impact the completion date. But not every single delay does that. Some delays happen and the project still finishes on time.
Right.
And to understand why that happens mechanically, we have to talk about float. It is the invisible currency of construction time.
Float is a fascinating, highly contested concept. Standard protocols define float values in a network schedule as an indicator of the relative criticality of activities. In simple terms, float is the amount of time a specific activity can be delayed without causing a subsequent delay to the overall completion of the project.
Okay, so if I have an activity like pouring the concrete foundation for a small outbuilding, and I have 5 days allotted in the master schedule to do it, but my team can actually pour it in 2 days, I have 3 days of float.
Broadly, yes, but we need to be precise. The industry distinguishes between different types of float, most commonly total float and free float.
What's the difference?
Total float is the amount of time an activity can be delayed without delaying the absolute project completion date. Free float is the amount of time an activity can be delayed without delaying the early start of the immediately following activity.
Got it.
The sequence of activities with the absolute least float, which is usually 0, is what makes up the critical path of the works. If an activity on the critical path is delayed by 1 day, the entire project finishes 1 day late.
Okay, here is the multi-million-dollar philosophical question that causes endless, bitter fights in arbitration. Who owns the float?
The age-old debate. The protocols lay out the two competing arguments perfectly. A contractor will aggressively argue that they own the float. They will say, look, I built this schedule, I intelligently added extra time to certain activities to give my team flexibility, to manage my supply chain risks, and to optimize my labor.
Which is smart planning.
Right. Therefore, if an employer risk event happens and eats into my planned float, I want an EOT for that time, even if the final completion date isn't technically breached yet.
And what does the employer argue back?
The employer says, absolutely not. The project owns the float. The only thing that matters legally is the final completion date. If I delay you on a minor activity, but you still have enough float in the overall network to finish the whole project on time, you haven't suffered any actual actionable delay to completion. So no EOT, you finish on the original date.
Wow. Where do the definitive industry protocols actually land on this battle?
The protocols decisively side with the concept that the project owns the float, which effectively benefits the employer's argument. Yeah. They state that unless there is an express provision to the contrary written into the specific contract, an EOT should only be granted to the extent that the employer delay is predicted to reduce the total float on the critical path to below zero.
So it's not enough for the employer to just cause a delay. The employer delay actually have to chew through all the available float and push the critical path past the agreed completion date to trigger an EOT.
Yes. The protocols explicitly say a contractor has no entitlement to an EOT merely because an employer risk event prevents them from completing the works earlier than the contract completion date, or because it takes away their comfortable float buffer on a particular activity.
But wait, if I'm a smart contractor and I know the employer can just eat my carefully planned float for free with their own mistakes, how do I protect myself? Do I just lie and create a schedule with zero float everywhere?
You don't lie, but you plan differently. The protocols have an answer for this. They advise that if a contractor wants to make a legitimate allowance for their own risks, like the risk of their own labor inefficiencies, equipment breakdowns, or normal weather delays, they shouldn't rely on generic total float scattered through the schedule.
What should they do instead?
Instead, they should include specific time risk allowances directly into the activity durations. So instead of saying painting takes 2 days with 3 days of general float, you logically program the painting activity to take 5 days, explicitly baking your calculated risk allowance into the duration itself.
Oh, I see.
Or you create a distinct, visible activity block called contingency for groundworks. That is considered prudent, transparent planning, and the employer can't easily steal that time without consequence.
Okay, let's test this in an assessor scenario. Candidate, we're reviewing a baseline schedule for a new data center. A major groundwork activity has exactly 3 weeks of total float available before it impacts the critical path. The employer breaches the contract and denies the contractor access to the site for exactly 2 weeks because they haven't secured the permits. The contractor immediately demands a 2-week extension of time, arguing furiously that the employer has stolen their planned buffer and the risk profile has now massively increased. Do you grant the EOT?
Under the recommendations of standard delay protocols, I would deny the EOT application at this juncture. The industry position on float is clear. It is an indicator of relative criticality, and it is drawn upon by whoever needs it first, whether that is the employer or the contractor.
Right.
An EOT is only triggered if the employer risk event is predicted to reduce the total float on the affected path to below zero, thereby actually extending the critical path to completion. In the scenario you provided, the activity had 3 weeks of total float. The employer delay consumed 2 weeks, therefore 1 week of total float still remains in that sequence. So no breach.
The overall contract completion date is not currently predicted to be breached. However, while I would formally deny the EOT, I would immediately engage with the contractor to discuss pacing. They may now legitimately choose to slow down other non-critical activities to match the new schedule dynamics, which is a recognized and acceptable mitigation strategy.
I love this. It's exactly like having a financial overdraft limit on your business checking account. Let's say you have a $3,000 overdraft limit. You are planning to keep that in reserve in case your main delivery truck breaks down. But then an unexpected, unjust bill from the city arrives for $2,000. They force you to pay it.
Yeah.
It eats up most of your overdraft. It's incredibly frustrating, it feels unfair, and your safety buffer is almost completely gone. But you can't go to your bank and demand an emergency extension on your loan terms. Why? Because your count hasn't actually bounced yet. You are still above zero. The bank, or in this case, the project schedule, absorbs the hit through the float. That is exactly how it works. Until the balance drops below zero, until the critical path is breached, the completion date doesn't move, and the legal mechanism of the EOT isn't triggered.
So we've established that the project absorbs single delays through float until it hits zero. But reality isn't usually a single, neat delay. What happens when the project is being attacked from both sides at the exact same time? Say the employer locks the gate, but the contractor forgot to order the concrete anyway. That brings us to the concurrency conundrum. What is true concurrency?
True concurrent delay is one of the most debated topics in construction law, but according to strict protocols, it's actually quite rare in practice. It is defined as the occurrence of two or more delay events at the exact same time, one being an employer risk event, the other a contractor risk event, where the effects of both are felt at the same time, and crucially, both must be an effective cause of delay to completion.
Meaning they both independently and simultaneously extend the critical path.
Yes.
Walk me through a timeline of true concurrency. Give me a tangible example.
The classic, almost theoretical example happens at the very commencement of a project. Day one, Monday morning. The employer completely fails to give the contractor access to the site because they haven't finalized the land purchase. That is a clear employer risk event.
Right.
But simultaneously, on that exact same Monday morning, the contractor has failed to mobilize any of their heavy equipment or workforce. That is a clear contractor risk event. Both events are happening at the same time, and either one of them alone, in isolation, would absolutely stop the project from starting and delay the critical path. That is true concurrency.
So if that happens, how on earth do you resolve it? Who wins the argument? The employer says, well, you didn't have your crane anyway. The contractor says, it doesn't matter, I couldn't get on the site.
The protocols recognize a very strict compromise solution for true concurrent delay, heavily influenced by English law. The rule is simple in theory, complex in reality. The contractor gets the time, but they do not get the money.
Wait, so the contractor avoids the late fee, but still has to pay his guys to stand around? That feels like splitting the baby. Break down the logic.
It is splitting the baby. Where contractor delay to completion occurs concurrently with employer delay to completion, the contractor's concurrent delay should not reduce any EOT due. So the contractor is granted the full extension of time. This successfully shields them from being charged liquidated damages by the employer.
But they don't get the money. Why?
When we talk about money and delay claims, we're usually talking about prolongation costs, the massive daily cost of keeping the site running longer than planned. Site overheads, equipment rentals, management salaries. The protocol states that the contractor cannot recover financial compensation for that concurrent period.
Why not? The employer locked the gate.
Because their own delay, failing to mobilize the equipment, would have caused them to incur those exact same overhead costs anyway, regardless of the employer's failure to provide access. The employer's delay didn't cause the financial loss. The contractor's own incompetence caused it simultaneously.
Okay, that makes commercial sense. But why does the law favor the contractor getting the time? If they were both equally at fault, why doesn't the employer get to charge half the liquidated damages?
Because of a very powerful legal doctrine called the prevention principle. This principle essentially states that a party, in this case the employer, cannot take advantage of the non-fulfillment of a condition, like finishing the building on time, if the employer themselves hindered or prevented that performance.
Oh, wow.
Even if the contractor was also messing up, the employer fundamentally cannot charge them punitive damages for missing a deadline that the employer's own actions made impossible to hit.
Wow. So the law essentially says you can't profit from a failure you helped cause, even if the other guy was failing too. Let's test the boundaries of this, because I imagine contractors try to use this as a shield all the time.
They do.
Assessor mode. Candidate, please analyze the following complex scenario. The contractor is performing terribly and has suffered a severe contractor risk event that will delay the critical path by 5 weeks, pushing the projected completion from January 21st to February 25th.
Okay, 5 weeks.
Independently, 3 weeks into this ongoing contractor delay, the employer issues a massive design variation. In the absence of the contractor's delay, this variation would have caused an employer delay to completion from February 1st to February 14th. The contractor argues this is a concurrent delay, they invoke the prevention principle, and they demand an EOT for the 2-week overlap. Do you agree?
No, I absolutely do not agree. What you have described is a very common misconception. It is not true concurrency, it is a sequential delay scenario.
Explain.
The industry protocols provide specific, definitive guidance on this based on established case law. For concurrent delay to exist, both events must be an effective cause of delay to completion. In your scenario, the contractor was already going to be delayed until February 25th due entirely to their own risk event. The subsequent employer variation, which would have only delayed the project to February 14th in a vacuum, is mathematically not an effective cause of the final delay.
Because it's swallowed by the bigger delay.
Exactly. The project was already going to finish later than February 14th anyway because of the contractor. Therefore, the employer delay did not result in the works being completed later than it would otherwise have been the case. The singular effective cause of the delay to completion is the contractor risk event. I would rule there is absolutely no concurrency here and no EOT is due for that 2-week period.
If a contractor doesn't understand that sequential delay rule, they could walk into arbitration expecting a massive extension of time and walk out with absolutely nothing, facing ruinous liquidated damages. If we strip away the legal jargon, what this rule is saying is you can't claim the employer's roadblock stopped you from crossing the finish line if you were already sitting down with a broken leg 5 miles back down the road.
That is exactly it. The employer's action has to actually be the thing moving the finish line further away. If your own actions had already moved it even further, the employer's action is totally irrelevant to the final date.
Okay, so we've covered the theoretical rules of the game. EOTs, float, concurrency. But how do you actually prove it? How do you do the math on a schedule that has 30,000 individual activities linked together? That brings us to the Forensic Delay Analysis Masterclass.
A real heavy lifting.
The protocols list 6 accepted methods for analyzing delay. Before we dive into the specific mechanics of them, what is the fundamental philosophical divide in how these methods operate?
The fundamental divide is between prospective analysis and retrospective analysis. Prospective analysis looks forward. It identifies the likely or predicted impact of a delay event on a future completion date based on a theoretical model. Retrospective analysis looks backward. It identifies the actual impact the delay events had on the actual as-built critical path after the fact.
The protocols also categorize these using the terms cause and effect versus effect and cause. What does that mean mechanically?
Cause and effect means you start your investigation by looking at the delay event, the cause, like a late design drawing, and you run it through the scheduling software to see what happened to the completion date, which is the effect.
Okay, and the reverse?
Effect and cause is the reverse engineering approach. You look at the final delayed completion date, the effect, and you trace back through the historical records to find out what specific events caused it.
Okay, let's decode the 6 methods. I want to walk a single hypothetical project through all of them to see how the logic changes. We have a massive 500-bed hospital project. It finished 2 years late. The contractor is claiming it was all the employer's fault. Let's start with method 1, impacted as planned analysis. What is it and how does it work?
Impacted as planned is a prospective cause and effect method. It is the simplest, the fastest, and usually the cheapest method to run. You take the original pristine baseline program, the schedule as it was planned on day 1 before a single shovel hit the dirt.
Right.
You identify the delay events, turn them into little subnetworks of activities in the software, and you simply insert or impact them into that original baseline. You let the software recalculate the critical path to determine the predicted completion date.
So if I'm the contractor, I just drop the employer's delays into the software, hit calculate, and say, look, your delays push the end date by 2 years. Pay me. Sounds easy. What's the catch? Why wouldn't I use this every time?
Because opposing counsel will laugh you out of the room. The massive, fatal limitation of Method 1 is that it completely ignores reality. It ignores actual progress. It assumes the contractor executed the job exactly as planned on day 1, which literally never happens on a hospital project.
Never.
It doesn't account for the contractor's own delays, their acceleration, or any resequencing they did. The protocols strongly note it should only be used if dictated explicitly by the contract, or if the delay happens right at the very beginning of the project before any actual progress has varied from the original plan.
Okay, so if method 1 is a fantasy, let's look at method 2, time impact analysis or TIA. This is one you hear about constantly in the industry. How's it different?
TIA is also a prospective cause and effect method, but it's vastly superior to impacted as planned. Instead of impacting the theoretical original baseline, you first take the baseline and update it with the actual progress of the works right up to the exact point just before the delay event occurred.
Oh, that makes sense.
You create a true snapshot of the project at that moment. Then you insert the delay event into that dynamically updated schedule to predict the impact.
I see. So it's much closer to reality because it uses the schedule as it actually existed, warts and all, on the day the delay hit. If the contractor was already 3 months behind when the employer caused a delay, the TIA model reflects that reality.
Exactly. It determines the impact contemporaneously. The industry highly recommends the TIA method for assessing EOT applications while the project is still ongoing. It provides the best real-time prediction.
But what if the project is already finished, like our hospital? We can't use predictions anymore. We have to move into the retrospective methods. Method 3 is time slice windows analysis. Walk me through the mechanics of slicing time.
Time slice is retrospective in effect and cause. This is where it gets highly analytical. You take the entire project duration and divide it into sequential slices or windows, typically monthly intervals that match the regular schedule updates. You analyze the critical path within each specific month.
Okay.
By looking at a series of these time slice programs chronologically, you can see exactly how the critical path shifted and evolved over time, and exactly how much critical delay was incurred within each specific window. Then you investigate the historical records to see what caused the delay in that specific month.
So it's very software heavy. You are analyzing schedule after schedule. But on a messy hospital project that finished 2 years late, the contractor probably stopped updating the schedule accurately somewhere in year 2.
What if you don't have good software data to slice?
Then you are forced to use method 4, as planned versus as built windows analysis. This is also retrospective in effect and cause, but it's much less reliant on complex software algorithms.
How does it work without the software?
Instead of arbitrary monthly slices, you frame your windows around major, undeniable project milestones or significant events, like substructure complete or building watertight. You determine the actual critical path in each window using common sense, logic, and factual project records, rather than relying solely on CPM software logic that might be corrupted. That sounds like a lot of manual reading.
It is. You compare the actual dates those milestones were achieved against the planned dates to find the quantum of delay and then investigate the cause. It requires the analyst to clearly and persuasively set out their rationale because the computer isn't doing the thinking for them.
Let's keep going. Method 5, retrospective longest path analysis. How does this differ from the Windows approaches?
Retrospective longest path is an effect and cause method, but it doesn't use windows at all. It starts at the very end. The analyst verifies or painstakingly develops a detailed as-built program, a master schedule of exactly what happened and when for every single activity.
Okay.
Then they trace backwards from the actual final completion date along the longest continuous path of actual activities to determine what the actual singular critical path was for the whole project. You then compare those key dates against the baseline to find where the delay occurred. The limitation here is that on complex projects, it struggles to recognize situations where the critical path rapidly switched back and forth between different sequences of work during construction.
And finally, the most complex, most expensive one. Method 6. Collapsed as built analysis, also known in the industry as the but-for analysis. Explain the mechanics of collapsing a schedule.
This is retrospective, but interestingly, it's cause and effect. It does not require a baseline program at all. Instead, it requires an incredibly detailed, fully logic-linked as-built program.
Which you said is rare.
Extremely rare in reality, so the claims analyst usually has to manually introduce thousands of logic links into the raw as-built data, which requires digging through daily site diaries, concrete pour logs, and emails. It is intensely time-consuming and expensive. Once that massive model is built, you identify all the employer delay events that occurred, and then you extract them. You literally collapse them out of the schedule logic.
You pull the delays out to see what would have happened but for those delays.
Precisely. You extract the employer delays to provide a mathematical hypothesis. When would the project have finished if the employer hadn't interfered? The difference between that hypothetical collapse date and the actual completion date is the net provable impact of the employer's delay.
That is mind-bending. The level of detail required for that is staggering. Okay, assessor time. Let's see how you apply this to a disaster scenario. Candidate, I need your expert opinion on a forensic methodology. We are engaged on a massive hospital project in the Middle East. It is currently 2 years post-completion. The project was an absolute disaster. The baseline program was poorly constructed from day one and was never accurately updated contemporaneously during construction.
A classic mess.
Exactly. However, the contractor's site team maintained meticulous, daily as-built records diaries, time-lapse photographs, resource logs. The contractor has just submitted a massive multi-million-dollar delay claim utilizing the impacted as-planned methodology to prove their EOT entitlement. Will you accept this analysis?
Absolutely not. I would reject the use of the impacted as planned methodology in the scenario outright, and I would advise the employer not to pay a dime based on it. As per standard delay protocols, impacted as planned is a prospective analysis that relies entirely on introducing delay events into a theoretical, unupdated baseline program. It ignores actual progress.
Which they didn't track anyway.
Right. Given that we are 2 years post-completion and we have a fundamentally flawed baseline that was never updated, inserting delays into that flawed model will produce nothing but a mathematical fiction. It proves nothing about what actually happened on site.
So what's the alternative you suggest?
Well, you noted we have meticulous as-built records. Therefore, a retrospective analysis is absolutely required to determine the actual effect of the delays. I would instruct the contractor to completely resubmit their claim using either the as-planned versus as-built windows analysis or the retrospective longest path analysis. Both of these methods rely on establishing the actual as-built critical path using the factual project records, which is the only reliable and legally defensible way to determine delay impact so far distant from the actual events.
Using prospective analysis after a project is finished is exactly like checking the local weather forecast from 2 years ago to figure out why your house flooded yesterday.
Yes, exactly.
It only tells you what the meteorologist predicted would happen. Retrospective analysis is the forensic autopsy. It looks at the watermarks on the wall and proves exactly what actually killed the schedule using the physical body of evidence.
That is a brilliant way to frame it. You simply cannot rely on a prediction when you have the historical facts readily available.
Now we arrive at Section 6, disruption, mitigation, and prolongation costs. We spent this entire time talking intensely about time, EOTs, critical paths, delay analysis. But time isn't always money in the way people think, and crucially, disruption isn't always delay. This is where a lot of massive claims fail in arbitration because they confuse the two concepts. Draw the hard line for us. What is the fundamental mechanical difference between delay and disruption?
The protocols make a vital hardline distinction here. Delay is concerned strictly with time. Specifically, it means work taking longer than planned, and usually it's focused on critical delay events that physically extend the critical path and push out the final completion date. The primary contractual remedy for critical delay is an extension of time.
And disruption.
Disruption, on the other hand, is concerned entirely with efficiency and productivity. Disruption is a loss of productivity, like severe labor inefficiency, having to constantly resequence work, or dealing with extreme site congestion on any activity, regardless of whether it is on the critical path or not.
So you can suffer massive disruption without suffering a single day of delay.
Absolutely. Think about painting the basement of our hospital. You could have a non-critical activity like that which gets heavily disrupted by the employer. Maybe they keep changing the paint spec, or they store equipment in the corridor so the painters can't move. It takes your painting crew twice as many man-hours. It costs the contractor a fortune in extra labor wages, but because painting the basement had massive float and wasn't anywhere near the critical path, the overall project still finishes exactly on time. There is massive disruption, massive financial loss for the contractor, but 0 days of delay to completion.
And what is the remedy for that disruption? Because they can't ask for an EOT.
The remedy is purely financial compensation for the lost productivity. You don't ask for time. You build a claim to prove the lost man-hours, and you ask for money.
Let's talk about the contractor's behavior when they are delayed or disrupted. We touched on this with pacing earlier. The protocols always state the contractor has a duty to mitigate loss. But how far does that go? If the employer delays the contractor by a month, does the contractor have to work 20/47 paying overtime to catch up and finish on the original date?
Generally, under common law, no. The protocols state that the contractor has a general duty to mitigate the effect of employer risk events. They must take reasonable steps to minimize the loss, and crucially, they must not take unreasonable steps that increase the loss.
But do they have to spend their own money to fix the employer's mistake?
No. Subject to express contract wording, this duty to mitigate does not extend to requiring the contractor to voluntarily add extra resources, hire more crews, or to work outside its planned working hours to recover employer delays. They don't have to spend their own money to fix the employer's mistake.
You mentioned express contract wording. I know we are focusing on the two main forms of contract today, FIDIC and JCT. Does the duty to mitigate change depending on which contract you are using?
Yes, it can change significantly. For example, standard protocols note that the UK Joint Contracts Tribunal, the JCT contracts, often include specific wording requiring the contractor to use their best endeavors to prevent delay.
Best endeavors. That sounds intense.
It is, and this specific phrase has been heavily litigated. Best endeavors may place a significantly higher legal burden on the contractor to actively overcome delays than the standard common law duty to mitigate found in other contracts. It might mean they do have to shuffle resources more aggressively than they would under a standard FIDI contract.
And what about pacing? We mentioned it briefly before with the overdraft analogy. If the critical path is delayed by the employer, can the contractor intentionally slow down the non-critical work?
Yes, and this is a major point of contention. The protocols officially recognize pacing. If an employer delay halts the critical path, say, structural steel is delayed by 2 months, the contractor might look at a non-critical activity, like installing drywall, that is running ahead of schedule. They will logically say, why should I rush this drywall, pay premium labor rates, and have it sit there getting damaged when the whole project is held up by the steel anyway?
So they just slow the drywall guys down.
Exactly. They can intentionally slow down that non-critical work to match the delayed relative pace of the critical path. The protocol's only real recommendation here is transparency. The contractor should formally notify the employer of their intention to pace the work and outline their logistical reasons for doing so to avoid it being misconstrued as a contractor delay later.
Okay, let's talk about the money involved when the whole project goes long. Prolongation costs. If the contractor successfully proves a delay and gets an EOT for 10 weeks, they're stuck on site for an extra 10 weeks. What kind of costs are they actually trying to recover?
They are seeking compensation for the time-related costs of staying on the project longer. This is totally distinct from the direct cost of doing the physical work. The concrete still costs the same amount to pour. Prolongation costs include direct site overheads. This means the cost of renting the site cabins for an extra 10 weeks, extending the tower crane leases, paying the site manager's salary, the security guards, the temporary power and water.
What about the head office, the corporate structure that supports the site?
That's a massive and highly contentious category, head office overheads. The protocols define these as the incidental, unabsorbed costs of running the contractor's business as a whole. The rent for the corporate headquarters in London or Dubai, the director's salaries, the IT infrastructure, the corporate auditor fees.
How does a delay on one site affect the rent in London?
The contractor's argument is that because their key personnel and bonding capacity were tied up on this delayed project for an extra 10 weeks, they were prevented from bidding on and taking on other profitable work that would have normally contributed to paying those head office overheads.
Proving that you could have won other work seems incredibly difficult. And when contractors get frustrated trying to prove all these individual costs, they sometimes just throw their hands up and submit something called a global claim. The protocols issue a massive warning about these. What exactly is a global claim?
A global claim is defined as a claim where the contractor seeks total financial compensation for a tangled group of employer risk events, but does not or cannot demonstrate a direct, specific cause and effect link between the specific loss incurred and the individual employer risk events.
So it's just a big lump sum request.
They basically take all the delays, all the disruption, calculate their total financial loss on the whole project, throw it all into one big bucket, hand it to the employer, and say, you caused a bunch of problems, I lost $10 million, I can't untangle it, so just pay me the $10 million.
I'm guessing assessors, employers, and arbitration courts absolutely hate that approach.
They despise it. Courts view it as lazy and legally insufficient. The protocols heavily emphasize that you must establish cause and effect. You have to link specific delays to specific financial consequences. Why do courts hate global claims? Because contractors frequently use them to hide their own incompetence.
Oh, really?
Think about it. If a contractor lost $10 million, maybe $5 million of that was due to the employer's delays, but the other $5 million was because the contractor badly underpriced the job or managed their labor poorly. A global claim tries to make the employer pay for the contractor's own bad business decisions.
Okay, final assessor challenge. Let's see if you can thread the needle between delay, disruption, and the right remedy. Candidate, here are the facts of the scenario. The employer forces the contractor's specialized painting crew to work in a highly congested area alongside electricians and HVAC installers, contrary to the agreed sequencing plan. The painting activity is not on the critical path and possesses ample free float. However, due to the severe congestion and overlapping trades, it takes the painters twice as long to complete the work, costing the contractor a significant amount in unexpected labor wages and overtime. The contractor submits an application for an extension of time, claiming delay to progress. What is your ruling on this claim?
I would formally and decisively reject the claim for an extension of time, but I would advise the contractor that they have a valid basis to submit a disruption claim. As established by industry delay protocols, an EOT is only granted when an employer risk event is predicted to extend the critical path to project completion.
Which didn't happen here.
Correct. Since the painting activity in your scenario was not on the critical path and had ample float to absorb the extra duration, the overall contract completion date was never breached or threatened. Therefore, no EOT is legally warranted. The contractor cannot have extra time. However, the contractor has clearly suffered a demonstrable loss of productivity, severe labor inefficiency directly caused by the employer's instruction to work in a congested area contrary to the plan. This is the exact definition of disruption. The contractor should be instructed to resubmit their claim, abandoning the request for time, and instead formulate a claim for specific financial compensation regarding the additional wasted labor hours expended due to the disruption event.
Okay, that makes perfect sense. The remedy has to match the disease. You survived the masterclass. I'm officially dropping the assessor persona.
Phew, that is an intense gauntlet to run through.
It is, but it's so necessary to understand the mechanics underneath the jargon. For you listening, we've covered massive ground today. We started with the foundational pre-contract rules of cost planning, understanding the stages from appraisal to production, mastering the strict definitions of GIA and NIA, and exposing the fatal dangers of relying on unadjusted historical data. Then we plunged into the post-contract warfare of contract administration, condemning the wait-and-see fallacy, unraveling the philosophy of who owns the float, and resolving the concurrency conundrum where you get the time, but not the money, due to the prevention principle.
And we went deep into the forensics. We decoded the 6 forensic delay analysis methods, separating the predictive prospective models like time impact analysis from the factual retrospective autopsies like the collapsed as built. And finally, we drew the hard boundary between claiming time for critical delay and claiming money for non-critical disruption, while exposing why courts reject global claims.
Mastering these concepts isn't just about passing a professional interview to get letters after your name. It is about preventing millions of dollars from being lost in the fog of a failing project. It's about stopping poorly structured global claims from clogging up arbitration courts and preventing sloppy wait-and-see contract administration from suffocating a project. But as we wrap up, I want to look at where this entire industry is heading, because while we've been talking about human analysts digging through diaries, the protocols give us a fascinating glimpse into the future of forensic analysis.
Yes, there is a brief but profound mention of something called system dynamics modeling.
Right now, we talked about a human analyst manually tracing an as-built critical path backwards through thousands of activities, or painstakingly injecting logic links into a collapsed as-built model. That is currently the gold standard. But system dynamics modeling is a computer simulation approach using highly specialist software. It doesn't just look at a static network of dates. It produces a living model that replicates the incredibly complex network of relationships, human behaviors, and interactions on a project.
It simulates workflows, it models labor productivity curves, it calculates the cascading effects of rework, and it even models the interactions and fatigue of different project participants. It resimulates the entire project dynamically to produce a flawless, multidimensional, but for model in what is essentially real time.
So here's the thought I want to leave you with today. If we are rapidly moving toward an era where AI-driven computer simulations can instantaneously model every microscopic interaction, every weather event, and every labor inefficiency on a massive construction site, what happens to the murky, diagnostic, muddy waters we started this deep dive talking about? Will the AI finally give us that clean, binary, black and white X-ray of a broken schedule? Will it be able to point at a screen and say, the employer owes exactly $4.2 million? Or, paradoxically, will the traditional human claims consultant become more vital than ever because someone still has to interpret the machine's findings, argue the legal nuances of the contract, and apply the human context of the law? It's a brave new world for construction claims, and we'll be here to dive into it next time.